This conference will now be recorded.
Hello, everybody. Jordan Girth here from the National Weather Service Office of Observations. Thank you for joining us for the Satellite Book Club Seminar Series. This is session number 69. Hope your fall is off to a good start. Great weather day for a lot of folks in the eastern United States. Today's presentation, the value of VIIRS, from Dr. Curtis Seaman, research scientist from CIRA in Fort Collins, Colorado. Our facilitator, Frank Alsheimer, Science Operations Officer at the National Weather Service Forecast Office, Columbia, South Carolina. Just a few reminders before we get started today that this session is being recorded. There will be an opportunity for Q&A after the presentation. And in that Q&A, we're particularly interested in feedback from our field offices. So if you may not even have a question, but you want to talk about how this has been used in operations or something you see that may be intriguing application for operations, please write it in the chat or indicate that you want to talk through your microphone. We'd love to hear from you. Everybody else, including forecasters, can post their questions in the chat and we will field them in the order they are asked. We're always looking for future presenters, so if you have an application you'd like to share, we'd love to have you as part of the Satellite Book Club, and the training team can help create training materials that may be unavailable or point you to where they are located. So Brian Mata, Office of the Chief Learning Officer, can take your questions on that. Thank you to our Tower S team, particularly Kashad Bowman, Lee Byerly, the Office of the Chief Learning Officer, and the GOES-R and JPSS program for their support of the Satellite Book Club. This goes off without a hitch every week because of their support. And just one announcement before we dive in today, and this is about GOES, but GOES 17 L2 products are now available over the SBN. Please contact the Tower S team through NWS chat. Interested users will go to the Tower S room on NWS chat. So once again, momentous day today. If you are in Western region or Alaska or Pacific region, you're interested in getting those GOES 17 level 2 products. Once again, those are the higher order derived products like TPW. Please follow up with our Tower S team if you'd like to bring those into your operations. So without further ado, let me introduce Curtis for today's talk. Curtis received his bachelor's from the University of Michigan, followed by his master's and PhD at Colorado State University in atmospheric science. He's been working at CIRA since 2012. Most of his recent work is focused on the development of multispectral satellite imagery products for hazard detection and production of imagery products for CIRA's Slider website. He's member of the JPSS and GOES-R imagery teams and member of the MET-IMAGE imagery team, which are being reorganized under the umbrella of the known as the STAR imagery team. So Curtis, welcome back to the Satellite Book Club.
All right, thank you. Thank you, Jordan. And good morning, everyone, or good afternoon, I guess, on the East Coast. So as my title implies, I'm going to be talking to you about VIIRS today, which is widely used up in Alaska region. And hopefully I can demonstrate that VIIRS does have value down here in the lower 48. But before I begin, I'd just like to take a moment to highlight the fact that weather satellites have now been around for over 60 years. The first satellite being TYROS-1, which launched in 1960. Basically, they mounted a black and white video camera onto a satellite, and this satellite wasn't even spin stabilized, so it only viewed the Earth roughly a quarter of the time as it tumbled around in its orbit. Of course, we've all learned a lot from these early missions, and technology has certainly improved since 1960, and now we have this new era of weather satellites that really got its start when JPSS first launched back in 2011. And now with the VIIRS imager, we have full global coverage twice a day from 2 satellites that provide a view of our Earth not only in full color, like you see here, but also a wide variety of RGB composites as well. And so that's what I'm going to be talking to you about today. And so hopefully everyone here has at least heard of VIIRS. Yeah, as I mentioned, it first launched back in 2011. So a little over a month from now, we will reach the 10-year anniversary of SUMI-NPP being on orbit. Then we got our second VIIRS on NOAA-20, which launched in November of 2017. So that's almost 4 years old. And of course, we're all looking forward to a successful launch of JPSS-2, which would become NOAA-21, and that is scheduled for about a year from now. So just to make sure we're all on the same page here and understand what the JPSS constellation is. So SUMI-NPP and NOAA-20 are the first two satellites of this constellation, and they are polar orbiting satellites, which, as the name implies, they orbit around the Earth by heading over the polar regions. And these orbits are called sun-synchronous, which means that they orbit over a given area on the Earth at roughly the same time every day. And these orbits are defined by their equator crossing time, or this LTAN, the local time of ascending node, which means the time that the satellite crosses the equator headed northward. And so both of these satellites are in the 1330 orbit, which means they're overhead in the early afternoon around 1:30 p.m. and again at around 1:30 a.m. And these two satellites are in the same orbital plane, but they're separated by half an orbit. And it takes roughly 100 minutes to complete an orbit. So this half orbit separation means that they're separated by about 50 minutes in time. And because the Earth is constantly rotating underneath these satellites, they end up, at least at the equator, they're separated by about 1,500 kilometers in space. But these orbits get closer together as they approach the polar regions. So what this means, this spatial distance is roughly half the width of a VIIRS swath. So the western edge of the first VIIRS overpass will be near nadir for the second overpass, and that same location on Earth will be near the eastern edge of the swath on the third overpass. So everywhere on the globe is guaranteed to get at least 2 overpasses from VIIRS every afternoon and in the early morning hours. But depending on where you are, relative to where these ground tracks line up, you can get as many as 4 overpasses here in the CONUS. One question that we often get asked is, well, when is VIIRS data going to be available for my region? And a great resource are the orbit tracks that are plotted up every day at the University of Wisconsin. So you can visit this website and find graphics like these that show when VIIRS is going to be over a given area at a given time. And anywhere within this white dashed line, this circle here, is within the range of the University of Wisconsin's direct broadcast antenna. So you can see they provide coverage over pretty much all of CONUS. And with this direct broadcast data, the data is typically made available within 20 to 30 minutes of the overpass time. So this graphic here is an example from last Friday, looking at the NOAA-20 or JPSS-1 orbit tracks. And for comparison, here are the SUMI-NPP overpasses for the same day. So as I toggle back and forth, you can kind of see how they're separated in space and time over the course of a day. So what can you do with this data? Well, VIIRS has 22 channels. Many of them are very similar to what you can get with ABI, except these are higher resolution than ABI. So we have 16 moderate resolution bands, or M bands, at 750 meter resolution. Then we have the 5 high resolution imagery bands, or I bands, that are 375 meter resolution, and the very unique day-night band, which I'll spend more time talking about later. And I want to highlight, a few of these bands here. You know, all of these I bands are much higher resolution than anything you can get on ABI. And I5 here is the highest resolution long-wave infrared band on any operational satellite today. I won't spend too much time talking about it, but I will be talking more about the 3.7 micron band, which at 375 meter resolution is quite an improvement over the 2 kilometer resolution you can get from the similar band on the ABI. And so this is very useful for fire detection. Then, as I mentioned, I'll be talking a bit more about the day-night band, which is a low-light visible sensor capable of providing visible imagery at night. And that has 750 meter resolution across the swath. And if you were here back in April for my previous satellite book club talk, where I talked about the snowmelt RGB, that product utilizes M8, this channel at 1.24 microns, which is not on any existing geostationary satellite. And I also want to highlight that not all physical processes require 1-minute imagery to be resolved. And there are many instances where having the high resolution information from VIIRS can make up for the fact that you only get a couple of overpasses in the afternoon and early morning hours. One example of that is you can produce the day-land cloud RGB at 375 meter resolution with VIIRS. And this is a great product for looking at flooding. And some of you out on the call may remember the high impact flooding event we had here in the Front Range of Colorado 8 years ago. So that was September of 2013, where the city of Boulder got roughly a year's worth of rain in a 1 week period of time. And what you can see from this animation is that the South Platte River Valley fills up with water thanks to all this rain. And you can actually track the leading edge of these floodwaters downstream all the way to North Platte, Nebraska. And North Platte received a record high river crest as a result of this event, even though they didn't get any of the rain that we got here in Colorado. Here's another example looking at the mid-Mississippi Valley. This was at the end of 2015, starting with a before image from mid-November, and to compare that to an after image on New Year's Day of 2016. As I toggle back and forth, you can see just how many areas experienced flooding as a result of weeks and weeks of heavy rain. Of course, it's easier to detect the flooding from this imagery if you have a before image to compare against, but you can also take advantage of the VIIRS flood product, which is on its way to becoming operational. And my understanding is that work is going on right now to add this product in AWIPS. And so this will take some of the guesswork and the subjectivity out of analyzing the imagery. Another thing you can do with 375 meter resolution is produce the day-land cloud fire RGB, which is very useful for detecting fire. So here's an example looking over Alaska, where you can see we have an active fire that is occasionally being covered up by some popcorn cumulus clouds, and you can also see the smoke plume headed off to the southwest. Now let's compare this VIIRS imagery with ABI imagery from the same time period. And it's, you know, some of these images, it's actually kind of hard to see that fire in ABI because the resolution is so coarse. And certainly you're not resolving any of these cloud features, and it's even harder to see the smoke plume as well. Of course, ABI's resolution degrades the further north you go, and so even though the main fire detection band on ABI has nominally 2 kilometer resolution, up at these latitudes it's maybe more like 4 or 5 kilometer resolution. But these benefits actually translate all the way down to the southern end of the lower 48. And so here's an example from earlier this year, looking at fires over the desert Southwest. Starting with an ABI image at its native resolution and from its native perspective, compared with the VIIRS imagery from the same time period. And let's zoom in on a couple of these fires here, starting with this fire over northern Mexico. So you can see that ABI saw the fire, but that's about the only information that it'll give you, is that there is a fire there. Whereas VIIRS, with its 375 meter resolution, actually gives you a lot more information about where the fire is and where it's actively burning. And so you can see it's more active on the southwest and northwest sides here. And you also can get a sense of where this burn scar exists that you can't really see in the ABI image. Heading over to the Shamrock fire in Arizona, right near the border with Mexico, ABI didn't even see this fire. And so, VIIRS, with its high resolution, is capable of detecting a lot of smaller fires that might be missed by ABI in its 2 kilometer resolution. And we've gotten some great feedback from users in the fire community. So I don't know if anyone out there knows Zeke Zeal, who works with the Alaska Fire Service. So he was positioned on a fire in Washington and was complaining about not getting NIROPS overflights, but says that the VIIRS imagery is an incredibly valuable resource for being able to map these fires, and the GOES just is not sufficiently high enough resolution to be able to do his job. You also get that same kind of benefit with the fire temperature RGB, although the fire temperature RGB with VIIRS is nominally 750 meter resolution. That's still better than the 2 kilometer resolution from ABI. And so here's an example of a fire that occurred up in Alberta a couple of years ago, looking at both VIIRS and both GOES. And you can see you get a lot more detail from this VIIRS imagery, not only more precisely being able to locate where the fire is, but also where it's most actively burning. So we have managed to get these products onto Real Earth, Sims's website that has a whole wide variety of VIIRS products on it. And so here's an example of the Dayland Cloud Fire RGB as displayed in Real Earth. And of course, you can overlay the maps on there, and you can look at the active fire product as well, the operational fire detection product, and see how well that matches up with the imagery. And Zeke was another big fan of this, that getting this RGB imagery available for CONUS was a real revelation to the fire weather community. We've also gotten the fire temperature RGB onto Real Earth as well, and you can see how well that compares with the active fire product. And we've also been working to get these products available in AWIPS. So here at CIRA, we are providing all the required VIIRS bands on our LDM server. And to make it easier for forecast offices to ingest these products, we break them up into smaller tiles so as to not overload the available bandwidth. And we're also working right now with the Tower S group to make these RGBs available more operationally and not just based off of CIRA's LDM server. I also want to highlight that earlier this year, I developed an algorithm for downscaling the fire temperature RGB to 375 meter resolution. So this requires taking the M11 band and downscaling it to 375 meter resolution. And again, you get a lot more detail at 375 meter resolution than you can even with 750 meter resolution. And so one of the things we are looking forward to in the future is working with the Tower S group to get this product into AWIPS as well. Now with the last few minutes, I'd like to say a few words about the day-night band, which is the one VIIRS product that every forecast office should have access to because it's delivered through the SBN. And so as I mentioned before, the day-night band is a low-light visible sensor that's sensitive to very low levels of light, roughly 8 orders of magnitude less intense than full afternoon sunlight. And so this allows you to produce visible imagery at night. So you can get a great view of the clouds at night, or in this case, Hurricane Ida, as it approached the Louisiana coast. You can also detect city lights with it. And occasionally you'll see lightning flashes, which show up as these bright streaks. Although I certainly wouldn't recommend replacing the GLM with the day-night band. And here's image from the next night after Ida made landfall. So I want to say a few words about the value of having visible imagery at night. It's great for detecting low clouds and fog, which you can see filling up the valleys here, the coastal range in Northern California. You can see the light emissions from fires, which are these rings of light up here. You can also see the smoke coming off of these fires as well. And, visible imagery is great for detecting aerosols. And so the day-night band is not just useful for detecting smoke, but it can also detect volcanic ash and dust. And lots of other things besides city lights and fires emit light at night, and you can see some of these as well. So here's an example from just a few weeks ago, looking over the northern high plains, where you can see quite clearly this smoke plume moving over Wyoming and eastern Montana with this day-night band imagery, and see if you can find it in the long-wave infrared. It's very difficult to see unless you have a very thick pyro CB cloud, because the long-wave infrared bands just are not sensitive to smoke in the same way that the visible wavelength bands are. And so here's what a whole night's worth of day-night band imagery looks like for this case. And you can see that the signal of smoke does generally kind of fade with time. It's a function of the viewing geometry and where the moon is relative to the smoke and the satellite. And I also want to point out that smoke is a lot easier to detect when you have moonlight available, as opposed to when you have a new moon case, for example, and this imagery gets a little bit noisier. Another thing you can do with the day-night band is monitor snow and ice at night. And so here's a long-wave infrared image looking at Colorado, and it's very difficult to tell where the smoke or where the snow is in this image. But with the day-night band, that snow shows up clear as day. Here's another example looking at Hawaii, and it is always fun to remind people that yes, in fact, it does snow in Hawaii from time to time. And so if you see these bright spots on the top of Mauna Loa and Mauna Kea, those are areas of snow that once again are very difficult to detect with the long-wave infrared bands. And I also want to point out, if you look at Maui here, the highest peak being Haleakala, which based on this long wave infrared image, you might think that it's cloudy up at the top of that peak. But the day-night band shows that it's clear. And so that's another useful feature, being able to detect not only when low clouds exist, but also when clouds don't exist and the surface is just cold. The day-night band can help discriminate in that instance. And this was a high impact event, so the Honolulu office did have to issue winter storm warnings, and they shut down the road up to the observatory because of how much snow they got out of this event. Here's another example looking at ice up in the Arctic Ocean, so north of Alaska. You can see this region of ice meandering around in the currents here in the day-night band image. And I defy anyone to claim they can see that ice in the long wave infrared image on the right. And we know that the Alaska Sea Ice Program uses day-night band imagery in their operations on a daily basis. And they've even used it in ship rescues because the day-night band is sensitive enough to see the lights from ships and can help ships navigate around this ice. And one place that does get ice in the winter here in the lower 48 is the Great Lakes. And so here's a day-night band image from back in 2014 when they had a near record coverage of the Great Lakes. And so you can see that Lake Erie is almost completely frozen over, and lots of ice on Lake Huron and Lake Superior. And knowing where this ice is important because that affects where the lake effect snow is going to set up. You know, once the lakes freeze over, there's no source of moisture for the lake effect snow. And, you know, once you have ice building up along the coastlines, that can impact the coastal erosion and have other impacts as well. And finally, I just want to head back to the Hurricane Ida example and mention that you can use the day-night band to monitor the impacts of significant weather events such as hurricane landfalls. So here we're looking at an image of New Orleans from before Hurricane Ida's landfall. And here's an image from afterwards. And so you can see just how many areas lost power as a result of Ida's impacts. And so this is a nice qualitative way to observe these impacts. And you can monitor this imagery over time and see where the lights start coming back on as power is restored. So just a quick summary here. You know, hopefully I've demonstrated that there are resolution benefits to VIIRS that outweigh the low temporal frequency of the data, and also that there are bands on VIIRS that you just can't get with any geostationary satellite. And we are working to get these products into AWIPS. And in the meantime, you can check out all the imagery I mentioned on our Polar Slider website and also on Sims's Real Earth website as well. And so I would be happy to take any questions.
Thanks very much, Curtis. That was a great presentation. A lot of really good examples of how the VIIRS imagery and derived products can help us out here in the CONUS. We're going to move on to the Q&A, but I've got a couple of housekeeping notes to make first. I really encourage everybody to stay on and have some participation, ask questions, or even give some examples of how you have used the VIIRS data in your operations. We're going to have a feedback survey that's going to be posted in the chat. You can see it pop in there. Please take the time, if you would, to click on that and fill out that survey. That helps us with making sure that everything we do in these satellite book clubs are useful to you and let us know if there's maybe additional ideas you'd like to have covered. Next week, the presentation is going to be given by Lee Byerly from the TowerS team, and he's going to provide a preview of the Tower RPM V22 capabilities. So that's the next RPM that will be in line, and Lee's going to tell us all about it. Of course, if you have any questions at all that concern the TowerS team, please feel free to reach out to Lee Byerly and Kashad Bowman. You can see their contact information on the screen there. So let's go right into the question and discussion. Again, please, if you have any questions or if you have something to say you want to ask verbally, maybe it's hard to write down in a question, but you'd like to ask or give an example of how you've used some of these products, just let us know in the chat room, and we'll be glad to either ask your question or make sure that your mic is available to be open so that you can ask your question verbally. So first comment I want to make, if you didn't see it in the chat, is Curtis nicely explained the day-night band. If you're looking at for it in AWIPS, it's actually called NCC, which is short for near constant contrast. I know I've used it in looking, for example, at inland hurricane information, where you get some additional information off of the day-night band overnight that you wouldn't be getting from just our standard infrared type of pictures that we're usually used to looking at overnight. As another question, we did mention, of course, that the day-night band or NCC is available on AWIPS. The question I guess I'd have to others is what process do we need to go through to get some of these other products into our AWIP system that aren't automatically sent over the SBN?
So if you are interested in receiving it from our LDM feed, you can contact me or you can contact Bill Line. He's the one who actually developed the configuration instructions. But my understanding is that these VIIRS fire RGBs and the snowmelt RGB should be added in the next RPM update. So hopefully we'll hear more about that from Lee Byerly next week.
Okay, great. I do have a question that's popped up here. It's from Bill Schoberg. You mentioned that there are PGRR initiatives, some of which are joint GEO and LEO initiatives. These initiatives are places to bring up good ideas that can be evaluated operationally and could result in improved operational application. So it's really more a comment than a question. But there are definitely things where GEO and LEO can work together. And the scientists are out there willing to help us out in the operational field. They just kind of need to be aware of where we think maybe something that we've done locally could potentially be looked at from a science perspective and added to everybody's either SBN or LDM feed for them to use. Another thing, you didn't mention this VIIRS product directly in this particular presentation, but I know one that I've looked at in the past is the NDVI to help with determining spring green up, especially dealing with the spring fire season. So the question I would have for you is this NDVI, is that something that's regularly produced, and do you know if it's available on any of the sites that you've mentioned already?
Well, it's definitely not on Slider. I know the data, the NDVI and other vegetation indices do regularly get produced, and I know that NOAA distributes that data off of the class website, but I am not aware of any efforts to get it into AWIPS.
Yeah, I don't know if anybody on the call uses that particular product, and if so, where they are getting the information. I guess we'll take that as a note to follow up for folks who might be interested in that. Any more questions from the field? Okay, I think we've pretty much exhausted the information. You can see that on the summary slide here, Curtis has his contact information along with Bill and Jarrell. So maybe those of you who watch this video after it was recorded because they weren't able to make it live, that's a great place to go and ask questions about that kind of information. It looks like we do have one question from Bob. And the question is, does illumination from cities penetrate through overcast lower clouds to be able to be viewed on the day-night band?
So yeah, the short answer is yes, most of the time. Let me go back here. So you can see with Hurricane Ida, that you can clearly see the outline of Jackson, Mississippi, and also New Orleans underneath all this thick cloud cover. I think there is a point at which clouds will become too thick and the city lights won't show up. But I think in most scenarios you can still get a sense, at least for the bigger cities, that those lights will penetrate the clouds.
Okay, question, Mike Stavish. The floor is yours.
Hey, Curtis. In the GOES slider, actually, I guess we'd be talking about the JPSS slider. The Sierra slider, the JPSS shows the DNB there, and it offers two options, the ERF scaling versus NCC. Can you speak about the differences of those two?
Yeah, so the NCC product, that's the operational product that NOAA produces, and that's the one that's getting sent out through the SBN to AWIPS users. The ERF is a version of the same thing that I developed to basically create similar imagery just using the day-night band data alone, so that you don't need to ingest a second product. So the raw day-night band data and the NCC are separate products that NOAA produces. And so I developed a version that's similar to the NCC, but uses purely the day-night band data and is not a separate product. That's the major difference.
Okay, thank you.
Okay, there's a comment in the chat for you all who can see it from Bill Line. It's got a little more detail on the smoke at night case that was actually shared in Curtis's presentation. There's also a couple of comments in the chat about the question that Bob asked. If you can see it, it seems to be depends on a few factors as to what you can see through those clouds. Lower intensity lights like small cities or interstates are going to be harder to see through the clouds versus larger cities or sources that have higher light. And Scott Lyncher mentions that he's seen MCSs over the Midwest obliterate slitty lights on the DNB, and not because they were causing power outages. It was a really heavy rain. So obviously, if you have really thick clouds, you may not see the lights at all underneath of them.
Yeah, that's correct.
All right, paging through the questions here, just a comment from Ivan is that there is an operational NDVI product that is generated by NDE. So the product is generated. The issue is I'll have to maybe look around to see exactly where you can find it. It's not in AWIPS, but it may well be available on websites, and maybe we can figure that out and attach it in the notes when we send out the link to the recorded presentation. And one other thing is Bill Schoberg wants to encourage people to check their SBN. He believes that there are capabilities that folks might not be aware of. We get into, of course, a lot of times we're creating procedures, and some of these procedures may have been created a while ago. And as some of these new products and information get put onto the SBN, we may not go back all the time and check that it's there because we get into the habit of just using our procedures. So it's a good reminder. Okay, I think it's time to wrap it up. So I'm going to pass it back to Jordan.
Thank you so much, Frank, and thanks everybody for the participation in the Q&A. I really appreciate, Curtis, you've taken the time for giving a presentation to the Satellite Book Club today. Next week on Thursday, October 7th, Lee Byerly from the TowerS team will provide a preview of the TowerS RPM version 22 capabilities. So I hope you'll tune in and join us again next week. And until then, if you have any questions about satellite products in AWIPS or about the Satellite Book Club, please get in touch with our TowerS team. They are standing by and they want to help facilitate the use of satellite imagery and products in weather service operations. So with that, thanks again, Frank and Curtis, for being with us today. Thanks to all of you for being out there. Hope your fall is going well. Stay well, and we'll see you again next week. Take care, everybody.